Hello, and welcome to Mastering Houdini Muscles, a studio-level workflow for visual effects. My name is Noah Schnapp, and I'll be your guide for this adventure. Over the last 15 years, I've had the pleasure of working as a rigging artist, character effects artist, technical artist, and developer with some of the best companies in the business. I've grown from a junior artist to a lead artist, and ultimately supervising entire rigging and character effects departments. I've been lucky enough to experience a wide variety of workflows and project timelines, such as feature film, feature animation, commercials, episodics, and video games. So let's suit up, dive in, hit the Houdini gym, and get our flex on. So let's talk about who this course is for, because there's a lot of different tutorial series out there catered to a wide variety of audiences. And so every time I make a series, I like to, first search, the internet, the marketplaces, see what tutorials are available for a topic that I want to discuss. And then, if there's a lot of interest, I really start looking at how can I make this tutorial different from all the others? How can I give something that is beneficial for not only large studios, but also individual artists? And so this series is really catered to this wide variety. It will apply to whether you're a studio with lots of resources, meaning lots of financial resources, lots of artists on hand, or lots of computing resources. It will also apply to individual artists that maybe are just trying to create a project on their own. So this is going to be a very robust and flexible and scalable workflow to where we can, regardless of your computing power, regardless of how many artists you have on hand, you can utilize this, and it will be a great solution for both types of teams. Okay, so what are we going to talk about in the series? So we're going to look at how to actually create this muscle pipeline, this muscle workflow. We're going to look at how to optimize it, how to automate it, and how to scale it. Because, there's so many muscle tutorials out there that only talk about one asset, and they tell you how to do that one asset extremely well. They go through the whole process, but at the end of that tutorial, it's like, how to do a bear really well, or how to do one person really, really well. And the truth of fact is, whether you're an individual or whether you're a studio, muscle work takes an extremely large amount of time. If you're an individual, you have to be almost a generalist, because you have to somehow acquire the muscles and bones, like whether that's turbo squid, whether that's you sculpting them yourself, whether that's, finding a model online. And then you have to have the technical artistry and knowledge just to create the system. And then you also have to have the time as an artist just to simulate it. And so there's a lot going on there. If you're in a big studio, there's a lot of moving parts. And, if you know how to do one asset really well, that's great for that one asset, but you really need a way to scale it. You need to be able to migrate your workflow and everything that you developed on that character to lots of other characters. You need to be able to reuse it. So one of the big things in this series is we're going to talk about reusability and the ease of migrating, because the idea is that, with that programmer mindset, you never really want to script or code anything twice if you can help it. So for this situation with muscles, if we do one body type, if like a biped, if we do a quadruped, we want to somehow be able to reuse that for all of that same body type. We want to look at how we can reuse limbs across multiple, different body types, if it's possible. We want to be able to reuse properties. We want to be able to reuse time, space, scale, or space, time, scale, whatever you want to call it. So, and that's basically like, whether you're simulating like Godzilla or you're simulating like Hulk. or like a very skinny person or skinny mouse. You're going to have different frequencies based on the size and the mass related to the world scale. So we're going to talk about all of that stuff. So we're going to, like I said, learn a pipeline that's efficient for large team studios as well as individual artists. We're also going to develop procedural workflows with generalized attributes to work for a variety of characters and setups. And so what that means is that I taught another training series a couple years ago with Ziva Dynamics, and Ziva Dynamics is amazing. It has been the best muscle solution for a number of years, and it was originally developed by Weta. It was acquired by Unity. So it's a force to be reckoned with in the sense of muscles for the industry. One of the challenges with it is that you get extremely good results, but there's not really a pipeline or workflow around what you're simulating. You kind of have to provide that. You have to craft that for your studio. In that other training series, we look at how to script the whole thing, and it's like 1,000 or 1,500 lines with like tools with IOs and stuff like that, and it works, and you can set up something fairly automated. But some of the attributes are a little bit sciencey. I'll put it that way. And that's not a bad thing. That just means that anybody working with it has to understand what these mathematic principles are. So we're dealing with things like Poisson's ratio, Young's modulus. We're not just dealing with like stiffness and dampening. And so that's one of the benefits of looking at Houdini over Ziva, is that it's catered to a wide audience, that it's more applicable to artists that aren't so technical, which is great for us, because the more you're a generalist, or like let's say if you're more animator than rigger, this will be easier to pick up. So most importantly, we are going to create a workflow that really allows multiple artists to collaborate with each other and work on various parts of the muscle pipeline simultaneously. And work on multiple parts of the same character simultaneously. And that's amazing, because if you have the resources of artists, you can really ramp up time and ramp up speed of the production. So we're gonna look at how as an individual artist you can utilize computing power, like have like almost a local topnet a local topnet running on your machine. We're going to look at how you can use deadlines to set that up to farm it out to multiple machines. But we're also going to look at how to split up the actual working on the asset or simulating the asset, and how we can work with multiple people, so we can get more done in a shorter amount of time. Lastly, I want to clarify that there are essentially two flavors of using muscles in the industry right now. There is shot and performance-based muscle simulation, and then there is pose and I guess you could say pose simulation based. Shot simulation, the first one, is where you are usually simulating for TV, film, something that's not an interactive experience like a video game. You have a start and an end to a shot. Something needs to already be happening at the beginning of that shot, like having pre-roll. And then pose-based simulation is more so if you had like PSDs, when the character goes into a specific pose, you want this muscle flex to happen. So the majority of this tutorial will focus on the shot-based workflow. So something that is catered a little bit more towards VFX. However, I'll say that everything in this process is applicable to the pose-based deformation. It leaves you in a situation where you can completely use that for something like generating the simulation for Unreal machine learning deformer. You can do something also more so for like a shot-based workflow where you'd be doing something for film or TV as well. So they're two very similar workflows. The main difference is that the shot-based workflow, I think, is a little bit more difficult because you have to account for all of the pre-roll automation and everything. The pose-based simulation is basically just a shot where you're starting from rest pose anyway, and that's fairly easy to do without any of the special sauce that we'll learn in this training series. So, the meat, the real gem of this training series is everything that it helps you set up for the shot-based simulation workflow and automating that, delegating it to a parallel evaluation through wedging or through farm rendering. So let's dive into it. All right, so let's talk about what's included in this course. So we're going to compare a variety of different muscle solutions, because really, over the course of the last 10, 15 years or so, there's been, many different technologies that have been utilized to produce the visual magic trick as muscles. You can have something as legacy and has stood the test of time as Maya C muscle, which that was originally my Comet muscle, and then I think it was absorbed into Maya through Autodesk. You can have something like Ziva, which Ziva Dynamics originally from Weta Digital, and then recently bought by Unity. Ziva used to be something for just bodies. Physically accurate simulations of soft bodies, and then that applies to muscles, and then full muscle systems, and then then they kind of evolved into Ziva Runtime or Ziva Real Time Trainer, which is similar to the Unreal Machine Learning Deformer. And then, from there, they also went into Ziva Face Trainer, which is, similar to the Runtime Trainer, but it's a way of producing a great looking facial deformation just from, wrapping a node mesh to their face and then running their cloud-based system. Ziva has kind of worked around or migrated around a variety of different areas. So I think they are still the highest quality and well used, most used everywhere. However, Houdini is coming fast up on their heels. It's Houdini, over the years, Side Effects has continued to improve their software, really listening to what artists say, listening to what companies say, what they want, working with them. And, they're really kind of outpacing these larger corporations like Autodesk. And it's crazy, like in Houdini, I'm actually a fairly new user to Houdini, only having used it in like a year and a half or so, and coming from Maya for most of my career. We're gonna just look at a lot of efficiencies that Houdini has over Maya. So if you're used to working in Maya and you don't have a lot of Houdini knowledge, don't worry. We're going to approach this from a very easy, generalized mindset, and we're going to talk about everything we're doing, working through all the networks, and it's crazy. There's it's like in Houdini, like I feel like the most commonly used realization is like, oh, there's a node for that, there's a SOP for that. And it's true. It's like there's a lot of complex tools in Maya and a lot of other DCCs that Houdini just has a node for, and it's just set up. So even though Ziva is very much used throughout the industry right now, I think that's just because it was like first to market, and it kind of was absorbed into all the pipelines. However, Houdini is really where muscles are going. It's whether you're an individual user, whether you're a studio, it's unbelievable the just the flexibility that you have within Houdini, treating everything as a dependency graph, and just the proceduralness, the farmableness, the versatility in all the nodes. It's not like Maya or another DCC where stuff is very specific. Houdini, if you can wrap your head around it, it's quite powerful. Okay. So we're going to look at how to create a studio-ready pipeline with little to no coding experience. And the reason why I think it's important to bring this up early on is that the previous muscle series that I did was very much the same title, but with Ziva Dynamics. So how to create a studio-ready workflow with Ziva Dynamics. And it did stand the test of time in a few different companies and stuff where like I'd integrated it. It was in my personal workflow, but my goodness, we had to code up to 1,000 lines, and it in that training series, there's definitely more with other integrations and things like that. But we were dealing with IOing attribute files, setting up controls, just writing a ton of code, writing this batch sequential workflow where it was importing files, assembling files, loading weights, and all of this. And it's you're kind of just at the whim of waiting for it to do all or nothing, or being there and monitoring each part every 5 or so minutes or so. And there's definitely ways that we talked about making things faster, simulating doing the automatic simulation. But one of the best things about Houdini is that you can create amazing workflows and pipelines with almost little to no scripting. So we're talking, small amount of Python, small amount of VFX, HScript, which is, natural Houdini language, kind of like Mel for Maya, but, HScript and VFX are very, very core to Houdini. So, even if you don't know any of that, don't worry. We're going to go over everything in the training series, but there is a fraction of the amount of code that we will write. And, for the code that we will write in the series is just to improve the workflow. It's not mandatory for the workflow. And, we're talking, less than 50 lines, more or less. So it's really powerful what you can do with the graphical interface of Houdini, and I strongly suggest everybody start investing, learning in that, especially with all the machine learning stuff that they have. It's crazy. Again, we're gonna be able to create this without having a need for a super developer, super programmer. We're gonna be able to do this if we just have general Houdini knowledge or general DCC knowledge, which is gonna be great. We're gonna create a beginning to end muscle pipeline with the perspective of zero coding experience. Like I said, we're gonna write a bit of HScript, VFX, and Python, but 95% of this training series will be through Houdini's graphical interface, which is awesome. Very, very cool that we just have nodes for these things. Again, no matter your programming experience, we're going to guide you every step of the way. And it's really, if you just have, basic, not even linear algebra, but high school math, add, subtract, you can understand this course. All right. Let's talk about the fun stuff. Let's talk about the advanced concepts that we're going to cover that you're not going to find anywhere else. So we're going to talk overall about how to complete a versatile muscle workflow that can radically speed up your projects in both VFX, games, and any other type of projects that you might come across. We're going to talk about automating pre-roll. And this is a huge thing. Ever since the start of character effects, we've needed to, have pre-roll for shots. What if you have a shot that starts mid-motion, somebody's like punching somebody and the shot starts midway through their punch? Well, the first couple frames are going to look inaccurate unless you have that pre-roll. And so there's kind of a long discussion about or debate about who is responsible for this pre-roll. The CFX artists don't want to do it because they feel like it's an animation job. The animators can do it, but it's hard to understand how long things should be. If you have pre-hold, if you have ramp up, if you need to dilute some of the locomotion because it's too strong and too powerful, too fast over a large distance. So we're going to talk about how to completely automate this. And I know that might sound like a holy grail to CFX, but we're going to talk about how you can automate this pre-roll, adjust it, and edit it purely as the CFX artist in a mathematical sense, to where none of the animation is, it won't have to rely on our artistic ability. We can just rely on our technical craftsmanship. Okay. So, like I said, with automating the pre-roll, we're gonna talk about automating, increasing, decreasing locomotion and limb momentum. So what this means is that, let's say, like for example, I used to work on a couple of different Marvel movies, and it's totally muscly people in tight-fitting clothing. So like, there's lots of muscles going on, there's lots of jiggle going on, lots of CFX. And, these characters, like if you look at one of the Superman movies, or, if you imagine like if you were trying to simulate like something like Dragon Ball Z or something, these characters are moving an extremely fast rate, an inhuman, physical, unnatural rate, because, they just need to almost teleport sometimes to get to places. And they are also traversing such a large distance, or they're so incredibly large, so incredibly small. Think of something like Ant-Man, and his simulation needs to look different, whether how big he is, how small he is, how fast he's moving, how far he's moving, like when he goes really small and jumps around very quickly. And, we need to be able to control this stuff. And so sometimes we need to dilute the locomotion. So we need to slow down or decrease the amount of movement the character is doing, and then we need to simulate it at that movement. So imagine it, instead of moving 10 feet, they only moved 1 foot. And then what we need to do after we simulate that at 1 foot is we need to re-inject that momentum inversely from how we slowed it down. Now, then we have actual per limb momentum. And so what that is that if somebody's punching or if somebody's running and it starts on that frame, it's going to look incorrect when, frame one, it's going to look incorrect for like the first couple of frames, because it's just not going to have that right momentum. So we're going to talk about actually choosing the start frame and then looking at the animation for all the limbs and then inversing that mathematically. So we don't have to rely on animation to actually, do that. We can just literally take their animation and inverse a duration of it. And we're going to talk about all the blending, all the pre-holding, all that stuff. So, we're not going to have a physical artist, physical person do this. We can control all of this just from the simulation standpoint, which is going to be great. Okay, so one of the most amazing things about Houdini is the fact that's like it's an operating system. It is so versatile within its application and outside of its application. And one of the coolest things that it has are top networks. So top networks top is a task operator. So a lot of things we're going to talk about in Houdini's, you'll notice that it's some letter and then it's OP. So SOPs, ROPs, chops, all these things are operators. So TOPS, task operator, SOP, surface operator, you've got chops, channel operator, ROPs, render operator. So we're going to look at how TOPS can delegate all of our simulation in a sequential manner, but also with parallel evaluation based on how many cores we have on our local machine. And then we're going to look at how to, log that, how to export it, how to do sequential simulations, and batch simulations. And then, in addition to, our top operators, we're going to look at how to wedge out these simulations. So wedging is essentially when, let's say that you have Hulk and you're like, I want, when Hulk's arm flexes, I want his bicep to increase. Well, I don't know if I want to increase 1.25 the volume, when it contracts, or do I want to increase two times the volume when it contracts? And what I'm gonna have to do is I'm gonna have to do two simulations where I set those two, variables each time, and I'm gonna have to have a human person do that, or I'm gonna have to have set up two scenes and then, send then on two different computers and hit go. And that's just gonna, it's not like it's impossible, but it's a little annoying to delegate that or do that by hand. So, or, wait for it, if you only have one machine. So wedging simulations allows you to set up any number of variable changes. So if you wanted to do a simulation where the bicep increased 1.25, 2.0, and 5.0, then you could set that up, hit go, and it's going to run all three of those simulations in a parallel manner, depending on your computer resources, or you can send that out via deadline and into a farm job. And then when you come back, you're going to have those three variants, and you can review those as opposed to only seeing one, and then after you see one, realizing, oh, we need to try another one. We need to try another one. So this is great if you have the computer resources and something's just sitting idle. Why not try a variety of wedged attributes and pick the one that you like the best? Because simulation is all about a race against the clock when it comes down to it. We're not at the whim of the artist and the amount of time or how fast an artist can do something. We are still we're still under the control of the computation power. It's not real time. We're getting closer there with Unreal, but we still have to wait for these things to simulate. So we need to be very, very sure in our planning and take advantage of any amount of time during the day, or more importantly, the night, and more importantly, the computing power that we might have on hand to perform as much simulation as possible in the most efficient manner. Okay, so we talked briefly before about data logging and notification. We're going to talk about in the top network how to log out to a file, how to do a more extensive log, as well as how to send an email once certain tasks are done, so that you can notify a group. And so you don't just have to be coming back to the computer, checking it out now and then. You can just set up automatic notifications, which is fantastic. And again, it's one of those things where you're like, Houdini has a node for that. It's like, it's true. It's just like they've really kind of taken these high level concepts in Houdini and made it very accessible for lots of different levels of artists, which is great. Okay, so lastly, we're going to talk about deadline farm submission with a server and a client machine. So Deadline is a render farm manager. It is, I think it was bought. It used to be its own thing. Then it was bought by AWS and Amazon Web Services, and so Amazon owns it. And it's kind of the standard. If you go to any studio, that's kind of the standard render farm manager. So, like usually when you log into your machine, you see a deadline window and you got to take your machine off the farm, or you're going to have a bad day when you're working. Just everything's going to go slow. Deadline is very versatile, very easy to set up, and very, when I say very versatile, I just mean a lot of different applications have plugins that can handle it. It used to be a little bit more difficult to set up with earlier versions of Houdini. Houdini 20 and onward just has like a very easy automatic setup for it, and it's just like built in. So once we learn how to set up top networks to really make the most of our local machine resources, we are going to learn how to set up a server and a client machine and farm out all of our task, which is, you know, extremely powerful if you're an individual artist. But oh my goodness, you can take advantage of so many resources and so much power if you're at a studio with this too. So this is going to be great no matter what type of artist you are. It's kind of been a black box to me in a lot of my career, but just looking at how it works, it's actually quite easy to set up. And the best thing about it is that it is free for 12 months. And free in quotes, meaning that they will, you know, if you have obviously a large team, or if you're pumping a lot of data, then you have to pay for it. But they've got a notification service and a kind of a governor service on it, to where it's like you can set your limit to like 0 or 1 cent, and if you go over 1 cent, it'll stop you or it'll send you a notification. So even if you want to just try this out, you know, same with Houdini. If you don't own Houdini and you want to try this out, you can do the apprentice mode in Houdini, which is free, and you can also do a free trial of Deadline. Everything that we're going to cover is free, and you know, it's great because you can get in here, you can understand this, you can learn it, and you know, you can use it for your projects.